Okay, sorry about that. I'm trying to get this thing lined up. This is okay. Congruent means the same size and shape. Similar, I would finish that. Similar means same shape, as we discussed in the last section. Same shape means equal corresponding angles, because it is the angles that give triangles, well, gives any similar objects their shape. It is the angles that have to be the same so that they can have the same shape. So if I tell you I've got two triangles here, and I tell you that this angle is equal to this one, as I've marked, and this angle is equal to this one, as you know, triangles have 180 degrees to go around. So if I have used up the same number of degrees here and here as I did here and here, there's the same amount left over for this one and this one. So it's not necessary to have all three pairs. Just two will be enough because the third pair will have to be equal to each other. And if all three pairs of angles are equal, which we have enough evidence for here, then we would say that these two triangles are similar. And the reason we would give for it is angle, angle, similarity. You have to put the little tilde on the end because it's not just angle, angle. That would be, we're talking about similar triangles, not congruent ones. So this is what it says. Two pairs of equal angles is enough, since the third pair would also have to be equal. Angle, angle, similarity for triangles only. This is only for triangles because they only have three angles, and so the third pair would have to be equal. Angle, angle, similarity is what this means. Okay, so here's how we're going to use it. Example 1 in the book says, determine whether the triangles are similar, and if they are, write a similarity statement. Explain the reasoning. So there's several things better to do there. First of all, let's determine if they're similar. So if this is 26, and this is 90, this is 64, and this is 90, how big would angle K have to be? Well, if I've already used up 90 degrees in both triangles, then that means that angle C, which is 26, and angle E have to add up to the other 90. So what I would do here is I would take 90 minus 26, and that would give me 10 minus 6 is 4, 9, 8 minus 2 is 6. That would give me 64. Oh, great. 64 goes there, and look where 64 is here. That means that 90 minus 64 over here would also be 26 here. I'm circling these because these are things that we came up with. Instead of were given. So what I've determined now is that these are similar. And I would write a similarity statement. This is how you would write it. Triangle. And then in the first one, usually we read them left to right. It doesn't really matter how you write, whether you do this one first or this one first. It's up to you. But usually you do what's left, just like you read. And so when you write down the three letters here, you can write them in any order you want. So I'm going to say CDE. But when you write what's similar to it, they have to correspond. So what goes with C, this little angle over here goes K first. And then I said D next, and D is the right angle, so that would be G. And then I did E last, and so that would go with the 64, it would be H. And it has to be written in this order. This is a similarity statement. And you can write the first set of letters in any order you want. You have to write the second one so that they match up. Okay, so there's your similarity statement. So first of all, are they similar? Yes, because they have at least two pairs of angles, a 26, 26, and 64, 64, but they actually have three pairs, 90, 90. Two at least pairs that are equal. So we've determined they're similar. That was the first task. If so, write a similarity statement, which we did right there. And then it said justify your reasoning. And the reasoning is just what we did up here. The reason is because of angle, angle, similarity. So yes, they're similar. Here's the similarity statement. Justify your answer, angle, angle, similarity. There you go. That's not that bad. Okay. Next one says in example 2, sorry about the bell, hang on. Example 2 says the same thing. It says show that the two triangles are similar, but that's all it says. Show that the two triangles are similar. Okay, so in this one right here, you can see, because of the way it's written, that this is equal to that. Oh, but look at how they're related. From chapter 3, we know that since these two things are equal and are considered corresponding angles, you can be sure that this line is parallel to this one, because equal corresponding angles imply parallel lines. Besides that, both the triangles, that is this little one here and this big one here, they both share something in common. this angle A. So I can get angle A equals angle A by reflexive. But I could also get this angle over here. I'll call it 1 and 2. I could also get that angle 1 was equal to angle 2 because I've shown that these are parallel. And since they are, these are corresponding angles and they are equal. So equal corresponding angles makes parallels and parallel lines make equal corresponding angles. So again, I got all three pairs. It doesn't matter which ones. We wouldn't have had to go with the parallels here if you understood that you had a reflexive A. You wouldn't have had to said the reflexive A if you weren't able to get this angle equals this one because of the parallels. But I just wanted to show you there's all three of them there. And so, yes, they are similar. And you would, if you would write a statement, you would say triangle EA. It doesn't ask us to do that, though. Well, actually, that's the way they write it. So to justify your answer or to write down what you concluded, you have to write. And I'm going to do the little one first. It wouldn't matter which one comes first. And I'm going to say EAB. That's got to be similar to, and I went EAB. And so it's going to have to go DAC because those correspond. And they are similar by angle-angle similarity again. Let's take a look at this one. There's nothing at all marked here. Nothing. Except that this is parallel to this. And if you have this parallel to this along this transversal, you can see, for example, that angle T is equal to angle R because they're alternate interiors on this transversal. Well, here's another transversal. So I could get that angle S is equal to angle U. And another thing that we've done with proofs before, you can call this angle 1 and angle 2, and they are clearly vertical angles. So you can get those as well. So again, along this transversal, I got a pair of angles. Along this transversal, I got a pair of angles, and I got the vertical angles in the middle, so I got all three. You would only need two pairs. You only need two pairs. But I'm just showing you that in this diagram, we could have gotten all three as well. And so we would say triangle SVR similar to, and we have to be really careful here because things alternate. Take a look here. This has got 3 marks on it. No, this has got 2 marks on it. This has got 2 marks on it. So if I said S first, and it's the double marked angle, I have to list U first. It's not going to go like this and then like this because with alternate interiors, they're kind of tipped over from each other. So S is on top. U goes with S. Then I went from there to V, so I'm going to go U, V, and then the last one is T. Make sure that you're doing it with corresponding marks. So this was double first in both of them, U and V. And then the triple, I went to the middle there and got V for both of them, the triple mark, and then I went to the single marked one for R and T. They've got to line up. And the reason, again, is angle-angle similarity. We could have said, I mean, we got all 3 pairs. We got at least 2, and that's what's necessary. Okay, example 3. This has to do with a situation. I'll read it to you so you can understand the diagram. Example 3 says, hang on, turn the page. It says, a flagpole casts a shadow that is 50 feet long. At the same time, a woman standing nearby who is 5 feet 4 inches tall casts a shadow that is 40 inches long. How tall is the flagpole to the nearest foot? So rather than have somebody shinny up the pole here with a tape measure and drop it down and measure it directly, we're going to use similar triangles. Are the triangles actually similar? And the answer is in the words at the same time. These are assumptions that you're always allowed to make. When people stand up, they're not usually. People stand up, they're perpendicular to the ground. When we put flagpoles in the ground, they're perpendicular to the ground. So we can assume that this angle equals this one. And we can also, because of the sun, it's the sun that's, I don't know if you can tell this, but it's the sun that's casting these shadows coming down like this. And the sun casts parallel rays coming down. So I can tell you for certain that this angle is equal to this one because when it said at the same time, it means the sun is in the same location for both. And you have to measure both shadows at the same time. You can't measure this one and then run over here and measure hers because the sun has moved a little bit in the meantime. But if it says at the same time, sorry about that bell. If they're measured at the same time, it means the rays of the sun coming parallel down like this makes this angle equal to this one. So we have angle-angle similarity, which means that the sides are proportional, which we discussed in 8.1. So I would say 5 foot 4. Now let's see, 4 inches, that's a third of a foot because 4 out of 12 is a third. So I'm going to say 5 and 1/3. And I really hate writing that because that makes algebra teachers nuts. But 5 1/3 is what I'm going to write there. 5 1/3 is to X as 40 inches is to, oh boy, Now we got trouble because we got 40 inches here and 50 feet here. Turns out, though, that proportions, and I'm going to do this a little bit. There's 6 different proportions you can write that are correct, but I'm going to make this a little simpler for you here. I'm going to compare inches. And you go, that's not inches. I'm going to compare inches to inches this way. This is to this as this is to this. That's one of the 6 possible proportions. Yes, I'm going to make this inches. 5 feet, 5 times 12. That's 5 times 2 is 10. 5 times 1 is going to be 60. Plus 4 is 64. So 64 inches is to 40 inches as X feet is to 50 feet. So as long as it's just you can go inches to feet. It's just kind of hard to put it together that way. I always try to stick with the same units in one ratio. Inches is to inches as feet is to feet, and it's long side is to short side as long side is to short side. You have to be consistent. But once you get that done, you can cross multiply. Now I could reduce that fraction on the left. I don't think I want to. I'm just going to grab my calculator and use the big numbers because it doesn't care. So hang on, we're validating here. Okay, so to cross multiply, I would say 64 times 50. That's 3,200 equals 40x. And so I take 3,200 and divide it by 40, and I get 80. 80 what? Well, this was inches to inches. This was feet to feet. And so that's an 80-foot pole is the height of the pole. And I'm here to tell you that is one tall flagpole. Because the one that's out in front of our school, which is really, really large, towers above the school that we've got, is 65 feet. So this is a pretty tall pole, but it's not unreasonable. But what we did is we found, first of all, the triangles were similar, understanding we were measuring at the same time, got this angle equal to this one. We understood or assumed that these were perpendicular. And then when we put the proportion together, I put inches to inches and feet to feet. Don't put 5 and a third here because that's feet. You don't want to go feet to inches and feet to feet. So I converted the 5 feet 4 inches to inches, feet to feet. And then if this was in the feet proportion, then the answer will come out in feet. That 80 is. Okay? Ooh, sorry. Ooh, had all that missing right there, but maybe you can catch up. Sorry, I wasn't watching the camera. Okay, moving along. Now we're moving on to section 8.3. We've done all the angle similarity stuff. Move this so that you can see it all. Okay, I'm going to turn to page 436. And this one says, if the 3 corresponding pairs of sides and, what was I going to write there? If the three corresponding pairs of sides in 2 different triangles are proportional, I think that's what I meant to say. Sorry about that. Bad writing. Okay. If the 3 corresponding pairs of sides in 2 different triangles are proportional, then the triangles are similar by what we call side similarity. They're not equal sides like we did side when we were doing congruent triangles. This is side similarity, which means all 3 sides have to be in the same proportion. Okay, proportional means ratios, equal ratios. That's what we got. So if we know that this triangle is similar to this one, then I know for sure that this short side compares to this short side the way this medium-sized side, BC, goes to RQ, the same as AC goes with PQ. In every case, big or small to big. And that's what I have right here. And again, we're only going to use them 2 at a time, either these 2, or these 2, or these 2. So, example 1 wants to know which of these 2 triangles here are similar to this triangle. Okay, so what I do is I look, and this is what you have to observe. I've got a short side here and a short side here. So what I'm trying to do is figure out if this one is similar to this one. This is short to short, middle size to middle size down here, and biggest one to biggest one. So what I want to know is, does 8 go with 6 as 12 goes with 9? Is that true? I'm wondering this. Are these equal? 12 goes with 9. Is that the same as 16 goes with 12? In every case, it was big to little. Well, let's see. We could cross multiply each one of these and find out, but we could also reduce them. This reduces to 4 to 3. This one, if I take a 3 out of both, is 4 to 3. This one, if I take a 4 out of both, is 4 to 3. So triangle ABC is similar to triangle, I have to be careful now, ABC is similar to DEF because each pair of sides were proportional in the same way. So now what I want to know is this triangle similar to this one. And so I write some similarity statements over here. I've got the shortest one, 8, and the shortest one over here is 8. So I want to know, is 8 to 8, is that the same as, I was looking for that here. Okay, 8 to 8, is that the same as, let's see, middle size 12 to 10? Certainly not. We can stop right there. They are not the same. This is 1. This is 6/5. So this is a big fat no. These two are similar. These two are not similar. This one's not similar to either one of these. Okay, so we compared proportions, and to figure out if they were the same, I just reduced them, and they reduced to the same thing. You could have cross multiplied. That is, 8 times 9, which is 72, is the same as 6 times 12, which is 72. 12 times 12 is 144, so is 9 times 16, 144. 8 times 12 is, I don't know what that is, but it's the same as 6 times 16, I can guarantee it, because these were the same. Okay, so you could cross multiply each set, or you can just reduce them to the same thing. All right, let's look at example 2. Trying to line that up. Hang on. Okay. Example 2 says, find the value of x that makes triangle ABC similar to DEF. So this time we don't know if they're similar, but we are going to force them to be. We want to force them to be by trying to figure out the value of x that makes these two similar. So what I do first is I hunt around for two corresponding sides that have numbers on them, not x's, numbers. So I see here a 4 and a 12. That tells me my scale factor. If I reduce it so the numbers are a bit smaller, that tells me that 4 to 12, my scale factor is actually 1 to 3. So my question, or not the question, but what I'm going to use is that 1 is to 3 as x minus 1 is to 18. Those two seem to go together. This one goes with this as this goes with this. So the first thing I did is I hunted down two sides, one in each triangle, that were the same side that actually had numbers in order to get a scale factor. Then I used two other sides, one involving an x and one involving a number. And that's supposed to be a minus, not a tilde. So then once I get these two together, and I know they must be proportional because I want to make these similar, I cross multiply. 1 times 18 is equal to, and when I take 3 times this, I'm going to distribute it. It's 3 times all of that, so it would be 3x minus 3. That means if I add 3 over here, I get 21 equals 3x, and that means that x equals 7. Now, just so you know, I could have also done this. I could have found the 4 and the 12. They have numbers on them. Reduce it to 1 to 3. And I could have also written 8 is to 3x plus 1. 3 times x plus 1, sorry. Because those sides go together. This 8 goes with this. That makes your life a little bit harder because this was a more complex statement than this was. But just so that you know, let's see if we get the same thing. If I take 1 times this, I get 3x. I'm going to take 1 times this. I get 3x, 3 times x plus 1, but I'm going to distribute it. Equals 24. Subtract the 3. 3x equals 21. Sure enough, x equals 7. So you could have gone either way with it. But if you think about it for just a minute, this is an easier expression to deal with, so you might want to make your proportion with the x minus 1. Just a little easier. But they both come out the same way as long as you don't make any mistakes. Okay, next statement right here. And I know I crammed it all together here, but starting right here with if. Okay? If a pair of angles in two different triangles are equal, remember the angles have to be equal when they're similar, and the sides attached to it are proportional, then the triangles are similar by side angle side similarity. So the question asks in example 3, are these two triangles similar? Well, notice I have a side angle side pattern for the given information. Side, angle, side. First thing I'm going to check is the angle in between those sides, are they equal? Sure enough, 53 equals 53. So I know angle F equals angle A. That's part of it. That's this part. Then I got to see if the sides are proportional. That is, does 6 go, the question is, does 6 go to 9 as, that's the question, does 6 go to 9 as 10 goes to 15? Well, this reduces to 2 to 3. This reduces to 2 to 3. So these two sides, these two sides are in the same proportion as these two sides, and the angle in between them is the same. Therefore, we conclude, because we have these proportional sides, and we have equal angles, therefore, this is a symbol for therefore, triangle and we say GFH is similar to triangle BAC because of side angle side similarity. That's our justification. Sides were proportional, angles in between were equal. Okay, there is a concept summary at the top of page 439, if you want to see that. It tells you these. We got angle, angle, side, 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 angle, side. I guess I'll show you in case you want to look at the book. Or it's kind of hard to view this and look at the book at the same time. So there's your concept summary right there at the top. Angle, angle, side, 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 angle, side. It's on page 439. If you need to look that up again, those are the 3 ways that we prove things are similar. And these are your practice problems. In section 8.2, 1 through 25, odd and 29, and 8.3, 1 through 9, odd, 10, 11, 13 to 18, and 20 to 26. And if you were taking my class in my brick and mortar school here, you would have both of these assignments to do in one night. If you're working online, these are sample problems that you can practice to make you better when it comes time to take the assessment. I think that's it. Yep, that's it for this section. And good luck. Let me know if I can help.